we'll look at this first question. So the first few look like they're properties of various things. So let's just review them. That way you kind of know what each one is. The commutative property, what it refers to is that order doesn't matter. Like A plus B equals B plus A. So order does not matter.
Right.
The associative property is kind of the one that's related to it. It says that if you add A plus B first and then add C to it, that's the same as first adding B plus C. And one of the big distinctions here is that there's 3 terms versus 2 terms.
Right.
Okay. And then the identity, we'll go with the identity property. I'll put that down here. So the identity property is like A plus 0 equals A, because the only way you get back to itself, the identity, is if you add 0.
Mm-hmm.
Inverse is undoing. You can think of undo. A plus negative A equals 0. Now, this is all informational. It doesn't, it in some ways has no help on this problem, but the problem itself, if we just look at this part, and it's a little bit confusing, but what they're telling you to do is let me actually just snip in the actual part here and work through it, because I think I've got too much on the screen here to be helpful. So if you just look at this part here and you take this right here, A plus BI, and put it in for X, minus A minus BI and put it in for Y. Let's see what happens here. So that's A plus BI. And then instead of Y, you write minus A minus BI. Do you see how these cancel?
Yeah.
So when they cancel, that's like the inverse property.
Yeah.
See how the inverse property it undoes?
Mm-hmm.
And A is undone with minus A, BI is undone with minus BI.
Yeah, I see that. Okay. It's inverse.
All right, let's look at number 3 next.
Mm-hmm.
And see if we can make some sense of this one. Yeah, we'll come back to 2. So it says which property is shown below. You've got A plus BI plus C plus DI. And then what I see is that the order is changed.
Right, they put like terms closer to each other.
Yes. Okay, so do you remember which property that is from starting out? Let me go back up and show you. So commutative was changing the order.
Mm-hmm. So then it'd be commutative.
It looks like it because there's no parentheses also. So yeah, let's go with that. I don't feel great about that because I don't really like the way this is written, but let's just go with that for the moment. Now, so let's go back to 2.
Mm-hmm.
Let me snip it in here. Okay, so what this is showing is that you start out with X and then you start out with Y, and it's the same as Y times X. So it's like this. What is 4 times 5? Does that equal 5 times 4?
Right. They both
answer-
equal 20.
Yes, and this is where order doesn't matter.
Mm-hmm.
So I would again call this commutative.
Okay.
Because commutative refers to order. Order doesn't matter. Now I have to be careful because like out of the first, both 2 and 3 are commutative, which doesn't really feel right because
right.
but
You could never do 2 at the same time. Like,
Yeah, it doesn't feel right. So if this is like for a grade and we're like really like this is really super important, I might consider changing 3, but I also might email my instructor and say, for Mr. Instructor, for number 3, it's the same, sorry, here's number 3. It's the same number of terms, which is
Mhm.
important. They're just in a different order. Okay, so to
Right.
me, that is commutative, but associative, see, here's the thing, is like if there were parentheses, we would for sure go with associative,
Right.
but
Because
there's
you're
not.
doing that.
So
Yeah.
I would like, but like because of what we just said, I may, if you don't have the ability to get in touch with your instructor, I may just go with associative, just because it's unlikely that there's 2 problems with exactly the same answer
Yeah,
in
I
this.
agree. They don't ever do that.
Yes.
It's tricky because it feels like it should have the parentheses.
Yes.
But I saying it's
Okay, so I'm going to switch to number 5. We will come back and do 4, but let's look at number 5. So the additive inverse means that when you add it to this, it equals 0.
right. I saw that like during school.
Yes, and we wrote that up here. So the additive inverse, it like undoes.
Mhm.
Okay, so what undoes subtraction by 8?
It would be a positive 8.
Plus 8. Okay, so that gets rid of those 2. How do you undo plus 3i?
You would negative. You would get a negative 3i.
Subtract 3i.
Okay. That's a little bit more simple. It's just doing the opposite of whatever's shown, like
Yes.
we did before with inverse. Just the opposite. Okay, that makes sense.
I'm just looking through the rest of the problems here. Additive identity. Identify property, additive identify property. Okay. All right. So there's a problem here, and I'm sorry that it seems like every time we meet, I have something that's unclear. Let's just say this was inverse.
Okay.
Let's just say that was inverse. I don't think it's inverse, but let's just say it was inverse. It would be just like the previous problem. Do you agree with that?
Yes, I do.
Okay. So the inverse tells you like what you add to it to make it 0, which would make the last one correct. Okay, because that would be just like the previous problem. We don't think that's it. This is mistyped. It should be identity. Okay, identity. And the identity property is whatever you started with, whatever you do to it, you better get back to the original.
Yes, and I double checked, and it is. I'm sure that I either typed it in wrong or it autocorrect me.
Okay.
It
Now
is
here's
identity.
so it has to be adding. It has to be adding, right?
Right.
So this one is also out because it's multiplying. So those two are out. So what I believe to be the correct answer is this one down here, the second one, because you're adding 0 and you get back what you started with, but
Right.
it's sort of missing some characters.
Mm-hmm.
Okay, because the identity means that you're adding 0 and you're getting back to what you started with. The multiplicative identity implies multiplication.
Well, not. I mean, we did go over. We kind of went over like the adding and subtracting of complex numbers and the multiplication.
Yes, and we're going to get to that. Like 7 to me is the last property. Oh, no, 10 is, and then we'll go back and we'll do some more.
Yeah,
So
they put a lot more property questions in here than they have done in the past. It's more, usually it's more just answering like actual problems.
Absolutely, yeah. Okay, so take a look at this. This one's the additive inverse. That means whatever you add to this is going to give you 0. That means it cancels with each of these.
Okay.
So what do you add to 9 to get back to 0? How do you undo addition by 9?
Oh, -9.
-9, yeah. How about minus 4i?
So +4i.
Plus 4i. So what is the correct answer here?
B.
I think I heard B.
Yes.
Okay, fantastic. All right, so we're going to go back to 7 next.
Okay. 7's a lot of numbers.
Yeah, so associative property generally refers to parentheses. That's why if we go, I'm sorry to keep going back and forth, but like if we go back to question 3, like I believe it's, unless it's written another way, and that's where you got to tell me.
Mhm.
Question number 3 does not have any parentheses. Do you see that?
Yeah.
That's why, like, I feel like it's the answer. Like if this is all I knew, I would say it's commutative every time. Associative only refers to parentheses. You got to have parentheses to use the associative property. And if you go down here, you got parentheses in every problem.
Right.
Okay, and I'll just show you again. It's A plus B first, then you add C, and then or you can first add B and C, and then add A later. But notice where the parentheses, it moves around. And so what you're looking for is where the parentheses is around, like the first 2 and then the last 2. Okay, so for example, see how the parentheses in this first problem, it's around the first 2 and then
Yeah.
the last 2.
Mm-hmm.
Okay. Second one though also is the same way.
Because they're just.
Yeah, so we'll come back to that. There's some weird stuff going on here. The middle one, do you see how it's multiplying here?
Yes, I do.
But we're dealing with addition, so we can't have any multiplication. So that one's out, gone.
That makes sense.
Okay, the last one has addition. It's +0, but that would be the identity property. The identity property is when you add 0.
Right, and you
Right.
get the same thing back.
Exactly. Perfectly said. So it means add 0. So that one's out also. So it's the first or the second. So let me snip each of those individually, and let's see if we can maybe inspect them a little closer. Have you already taken geometry?
Yes, I have.
Okay. One of the techniques that I like to tell students about in geometry, sometimes you got to add lines and subtract lines, or you have to draw, you have to separate things. And that's what I'm doing for you here, because when we look back at the answer space, there's just too much going on. So let's get a fresh start here. Okay, and let's just look at them. So on the left here, there is no equal sign, but let's assume there's an equal sign right there. Okay. So it's on the left here, it's -4 plus I plus 4i equals, and on the right, it's -4 plus, what is that? Let's go with I. Let's say it was capitalized. I don't know. So the question for you is the only thing that changed the order of the parentheses, like if they're around here and then they're around here, is it exactly the same order? Is it, and I'll draw this underneath, is it A plus B plus C equals A plus parentheses B plus C?
Yeah, that is what it shows.
Yes. Okay, so we know that this is correct. Now the one on the right has kind of some similarities, but you'll notice the order isn't the same. See how the first term here is, but it's 4i, and that's different than order doesn't matter. It's that you have to, the associative property has parentheses and in the same order.
or it doesn't.
So I think this was the first one, letter A,
Yeah.
if you're keeping track.
Mhm.
All right, now we skipped a bunch here. I obviously want to go back. The rest of these are more like what I would consider to be the problems you would see on a test or quiz.
Mhm.
But given your class, I wouldn't know that for sure. So let's actually do 8 first. We will go back to 4, but 8 is an adding and subtracting, which is easier
Mhm.
than multiplying or dividing.
I have a hard time with these type of problems, just keeping track of what is negative and what's being added and like stuff like that. I have a hard time like making sure that it stays the same.
Yeah,
Or-
that's a common thing. So that every standardized test I've ever seen, they always have a problem where you have to distribute the negative to both terms.
Mhm.
And that's what you're referring to. You have to remember to distribute the negative to both. And that's all they're testing. So it's a negative here, positive here, it becomes -2. Do you agree with that?
Yes,
Negative times a negative is,
a positive.
so plus 6i.
Mhm.
And then the parentheses are not needed. Why are the parentheses not needed? And the answer is that there's nothing in front. There's no operator. Whereas on the right here, the operator is the subtraction.
Right.
Okay. So let me write this a little cleaner. More of the flow you would expect to see where everything's kind of right next to each other. There's a little bit too much space there. But you now combine, I think I heard you say this earlier, like terms.
Yes.
Okay. And then you combine the other like terms. Now you don't have to rewrite it. You can, like if you want to write 3i plus 6i and you want to write -7 minus 2, like you can totally do that. Or you can just be like, hey, I know what -7 minus 2 is. It is -9.
Mhm.
And I know what 3i plus 6i, well, I know that's
9.
9i.
And that's
All right. So if you think you understand that, I would like to have you do a problem like this on your own.
okay.
So do you have these notes down? And if you don't, please take a moment here to copy it down before we do another problem, because it's going to be just like it, except it'll be slightly different numbers.
Now I have it copied down.
Great. All right, so I want you to, and it could be written like this. It would just say, to simplify,
Mhm.
-6 plus 2i minus 4 minus 3i. So take about a minute, and you're welcome to look back at your notes from the previous problem. I promise you, it's basically the same thing with just different numbers. Try to do the same set of steps that I did and see how you do. And I'm just going to step away for like 30 seconds.
Mhm. Okay, I think I got it.
All right, Emma, I'm back. How are you doing on this one?
I got -10 plus 5i.
Sounds right to me. I'm gonna just write your answer there and show the steps in case you want to look at it later. So the negative gets distributed to both here.
Yeah.
And that's why your answer sounded so good, because it's -4 plus 3i minus 10 plus 5i. Very good. Okay, so let's do another problem here like this. We've got enough time. We're going to get through everything. I assume this is all you want to work on. So is it okay if I interrupt with some problems like this?
Totally. These are more problems that I'm gonna have to deal with. So
Absolutely. Yeah. So let's do another one. Let's say it's -5 minus 6i minus 4 times 3i minus 2. So this time, what's different about this problem is it's not just a negative out in front, it's a -4.
Mm-hmm.
So you take this whole thing and you apply it to both. And I think there's some confusion that happens here, but when you treat this as -4, there's really like a plus right here.
Right, because it's a -4, it's not your minus sign anymore.
Exactly. So that really well. So it's plus, and then it's -4 times 3i. Now you might write it this way, which is okay. Okay, or it's -4, and then it's -4 times -2, which is +8. And then it's just like the last where you combine like terms. You combine these two, 3, and then the other two minus 18i. So please take your notes down on this one. I'd like to give you one just like it to do.
Okay, I have them down.
Okay. So let's go -8 plus 2i minus 3 times 2i minus 6. So take about 30 seconds and I'll check back with you and see how you're doing on this one.
Okay.
All right, Emma, how'd you do on this one?
I got 10 -4i.
10 minus 4i like that?
Yeah.
All right, so let me work it out here. That does look pretty good. So it's -3i times 2i, that's -6i. And then -3 times -6 plus 18. So if you combine like terms, you get 10 minus 4i, perfect. All right, so let's move on to multiplication.
Mm-hmm.
And we will finally go back to 4. All right, so 4 says evaluate, and it's referring to multiplication between them.
Mm-hmm.
you actually do have to substitute these in. So that's 2, and that's 5i. So we got 2 minus 5i, 2 plus 5i. And do you remember us talking about FOIL?
Yes, I've been for other problems kind of like this. I've been using FOIL, your pamphlet, and just looking at it made it a whole lot easier.
Excellent, excellent. That's great to hear. So we're going to do that here. We're going to do the first term. We're going to do f2 times 2. That's 4.
Mhm.
Then we're going to do the outside, which is 2 times 5i. That's 10i. Just color coding it here. Go with red. So that's minus 5i times 2. That's minus 10i. And then I don't really have a color for the last, but we'll go with this. We'll go with this this yellow here.
Mhm.
That's these, and it gives you minus 25i. Boy, that didn't come out very well. Let me just fill that in here. Minus 25i. Okay. So I'm sorry, I squared. I apologize, I squared. So you probably notice right away that these middle ones cancel.
Yeah.
There's a reason that they cancel in this problem, but in general, they do not.
Okay, so usually when you're not like doing FOIL, would you say that they don't cancel?
Yeah, normally you get what's called a middle term, and
Mhm.
this one does not have it. So you're down to this line here, and you might think, hey, I'm done. But you're not. The answers don't match up. I squared equals -1. Sometimes it's written this way, where the square root of -1 equals I. But the form right here, this is the more useful form.
Mhm.
So instead of I squared here, we're going to replace it with -1. And that becomes 4 plus 25, because minus 25 times -1 is positive 25. And that equals 29.
Okay. I had a hard time with this at first because I was confused about why the I would get changed and I would put the I on the problems. But I see how you make it into the -1 and put it into the
Yeah.
problem instead of the I.
Yeah. So it looks like if you're looking, looks like letter D is the correct one there.
Yes.
Let's do another problem like this together. Do you have all your notes down here?
Yes, I do.
Okay, let's do another one together. So let's go 3 plus 4i, 3 minus 4i. And we're going to FOIL this time. So what is 3 times 3?
3 times 3 is 9.
9. Okay, then you do the outer. 3 times -4 minus 12i. Then the inner is 4i times 3, which is, again, 12i. And then the last is 4i times -4i minus 16i squared.
Okay. And then we just take.
So notice these cancel,
Mhm.
and you get 9 minus 16i squared. I squared is -1. And so you plop that back in. 9 minus 16 times -1. 9 plus 16. Total of 25.
Okay.
So I'd like you to give you one to try on your own here. But before I do, is there any questions on this? Because it's going to be really similar, just different numbers.
No.
Okay, so here we are. Let's go with this one. 5 minus 6i, 5 plus 6i. So take about a minute, see if you can work that out on your own, please. How are you doing on this one?
Okay, I got 61.
Okay, so that sounds right. Let's just work it out here in case you want to look at it later.
Mhm.
The outer is plus 30i, the inner is minus 30i, and the last is minus 36i squared. These two cancel. I squared is -1, so it's 25 minus 36 times -1. 25 plus 36, which is 61. Yes.
Okay.
All right. So let's look at number 9, which I think we actually just did. Nope, we did not do it. I didn't realize 9 was exactly the same. So let me actually have you try it on your own, and then
Okay.
we'll do some that are different so you can see what the next type of problem you will see. So go ahead and take a look at that. I'll be here if you need anything. Do you have a final answer for that one?
Yes, 13.
Yes. Great. Okay. So I would like to move into new territory. It'll be things that you haven't yet seen. Is that
Mhm.
okay?
That's fine.
All right. So you will probably see it in your next homework assignment. So it would start out with something like we just did 7 minus 2i, 4 plus 3i. Okay, so the reason all those problems we just did turned into a number is they are what are called conjugate pairs.
Well, they're like the same thing, but
But they differ right
yeah.
here.
Yeah.
Okay. So they always produce a number. Everything else does not. And we'll see some examples here. This is what I was expecting you to have to do first. This is kind of the more common approach. So you just FOIL it again. You get 28 plus 21i minus 8i minus 6i squared. So notice that the outer and inner do not cancel this time.
Mm-hmm.
You get 13i, and then 6i squared is really minus 6 times minus 1. So you get 28 plus 13i plus 6. And then you do combine like terms. So the answer is 34 plus 13i. So it's just a FOIL problem. This is just a FOIL problem. And I'll make a note here that the instructors really want to see it in this form. If you were to write 13i plus 34, they would say, maybe, they may not give you full credit for that.
Right. It has to go back into the A plus.
It has to be in this form. I mean, that we can talk about why, but that's just the way it goes. So I'd like you to try one of these on your own, and then we'll move on to something else that I think will be a little more difficult. So let's go with 6 minus 2i, and then 4 plus 5i. If you could FOIL that and simplify, please.
Okay.
How are you doing on this one?
Still working on it.
All right. Let me know when you're all done.
Mhm. Okay.
You got it?
Yes.
Okay,
20.
hold on to your answer. I'm going to FOIL,
Mhm.
and you just check and see if you get something similar, or see if there's any issues. So plus 30i minus 8i minus 10i squared. Okay, so this becomes 24 plus 22i minus 10 times -1, 24 plus 22i plus 10. So it becomes 34 plus 22i. Is that what you got?
No, it's not. I don't
Okay, where is your mistake? Is it in line 1, 2, 3?
I forgot to do the -1 and kept it as an I.
So yeah,
Like
so
a
you go,
10.
this is important, right?
Yeah. No, I forgot.
Okay, let's do another one. I gotta have you do this all the way through.
Yeah.
So it could be 4 minus 3i, 5 minus 6i. Like they can both be negative, they can both be positive. One can be positive, one can be negative. But go ahead and work through this one for me, please. How are you doing on this one? Say again. Sorry.
I finished.
Okay, let me FOIL here and see if we get the same thing. And then you got minus 24i, minus 15i. This time though, see how it's a negative times negative? So that's plus 18i squared. So when you combine these middle ones, you get minus 39i plus 18i squared. I squared is -1. So we have 18 times -1, 20 minus 39i minus 18. And you can combine these and you get 2 minus 39i.
Yep.
You got it?
Nope. Oh, what did I do wrong this time?
So where was your mistake? If it was at line 1, line 2?
It was line 1. I put a negative 18 instead of a positive.
Okay. So you did say you had been working on that FOIL worksheet.
Yeah.
Okay. Let me just really quickly pull it up and see if I can maybe help you navigate this. So let me share the worksheet with you.
Mhm.
And if you're seeing my screen, there are 3 types of problem sets. The first one is this plus case. And it's really no different than what we're doing with these problems here. It's just you got eyes. Now the answer is kind of interesting. See how the answer also has a plus in it?
Mhm.
Now, when we go to type 2, if they're both negative here, okay, the answer is negative positive. And that may help you to see patterns
Mhm.
that I know you see when you read things, but in math, it's just a different type of patterning. Type 3 are where there's 1 plus and 1 minus, 1 minus and 1 plus. We don't know the order, but the answers are always, well, they change. So this is the hardest one when they're one's plus and one's minus, one's minus, one plus. But the good news is if they're both plus plus, you know that it's plus plus here.
Right.
If they're minus minus, you know that it's minus plus.
Mhm.
Unfortunately, the last one is not like this. So the reason I bring this up is let me go grab a type 3 here. You said you had been working on these. So watch this. Actually, let me cancel that. You can actually do, let's just say 59 here. I'm going to snip that back into the workspace. This will be the last thing we probably do today.
Okay.
Let me snip that in here. You can take a problem from this worksheet and you can just slightly modify it. You can go 3i plus 5, 8i minus 2, and you can FOIL this.
Mhm.
So let's look at that together. So that would be 3i times 8i, that's 24i squared. 3i times, is it 2 or minus 2?
Minus 2.
Minus 2 because the operator goes with it. So minus 6i plus 5 times 8i, that's plus 40i. And then 5 times negative 2 gives you negative 10.
Uh-huh.
Okay, so now I squared is negative 1. It's 24 times negative 1.
Mhm.
These right here make plus 34i minus 10. And this right here becomes minus 24. And so these combine, you get minus 34 plus 34i.
Mhm.
Okay. Now, if you go to the answer key, this is where this might be helpful. This is what I'm trying to show you real quick here at the end.
Yeah.
Here's the answer. Let me snip that in. And F is really I. And F squared is really I squared. Does that look exactly like this line here?
Yes.
It does. So you can absolutely use this FOIL sheet. You just have to, when you look at the answer sheet, make sure you make these small changes because this becomes minus 24 plus 34i minus 10. I know it's a little extra work, but it could help you here
Mhm.
for that. So
Yeah, another thing I realized that I was doing was because the last number in these equations that you've been giving me had an I kept on adding them with the number with an I or subtracting them.
yeah,
But I
yeah,
wasn't changing the other one.
yeah. Do you have some time today or maybe tomorrow to just do a little more practice?
I will, yeah, I do have some time. I'll try
If
to make sure I practice a little more.
if you have even just 5 or 10 minutes, it will make a huge difference, believe it or not. It's more about how often you do stuff than the amount of time. So
Mhm.
if you can, great. I'm sure your dad will be really happy. Maybe it can translate into some other books you can read, get some time for that or something. I don't know. But that probably is it for today. If you're okay with stopping here just a minute early. I
No,
really
that's fine.
thanks so much for scheduling. I look forward to helping you next time, and I hope you have a great night.
Yes, thank you for your help.
You're welcome. Bye now.